Let us look at proposition number 15 of book 9 of Euclid's Elements. The proposition says, if three numbers in continued proportion are the least of those which have the same ratio with them, then the sum of any two is relatively prime to the remaining number. So the proposition is saying that we are given three numbers which are in continued proportion, A, B, and C, such that they are the least of such numbers. Then the sum of any two of these numbers will be relatively prime with the third number. That is, A plus B will be relatively prime to C, B plus C will be relatively prime to A, and A plus C will be relatively prime to B. Okay, let's see how we can prove this. Given three numbers A, B, C in continued proportion such that they are the least in the ratio. Take two numbers D, E, and E, F, two numbers least in the ratio A, B, C. Which means what? Since they are in continued proportion, A will be DE times DE, that is DE square. D will be DE times EF. And C will be EF times EF, that is EF square. Remember, DE and EF are the least numbers. So which means that they are going to be relatively prime. And DF, which is the sum of DE and EF, that is DF, is relatively prime to each DE and EF. So DF is relatively prime to DE, DF is relatively prime to EF. Again, this is based on one of our previous propositions. Now, DF, DE are relatively prime to EF. So here we said DF is relatively prime to DE plus EF. And now here we are saying DF is relative, DF and DE both are relatively prime to EF. DF times DE is relatively prime to EF, which means DF times DE is relatively prime to EF square, again based on one of our previous propositions. But DF times DE, DF times DE will be equal to or is equal to DE square plus DE times EF. You can work it out and see. Again, this is based on one of our previous propositions. So since DE square plus DE times EF is equal to DF times DE, and we have said that DF times DE is relatively prime to EF square, we can say DE square plus DE times EF is relatively prime to EF square. Now, what is DE square? DE square is A. DE times EF is what? B. So A plus B is relatively prime to EF square, that is C. Let's look at another case. DF is relatively prime to DE and EF. Means DF square is relatively prime to DE times EF. Now DF square is nothing but DE plus EF square. Right? So we can write it as DF square equal to DE plus EF square. And we know how to resolve this. So DE square plus EF square plus 2 times DE times EF. And since that is equal to DF square, we can say DE square plus EF square plus 2 times DE times EF is relatively prime to DE times EF. Another way of looking at this is saying that the GCD of DE square plus EF square plus 2 times DE times EF and DE times EF is equal to 1. Now, here from the first number, if we add or subtract multiples of DE times EF, the GCD would still be 1. This is a little bit tricky, so let me take an example and do it. Let's say DE is 2, EF is 3. So 2 square is 4, 3 square is 9, 9 plus 4 is 13. 13 plus 2 times DE times EF. 2 times 3 is 6. 6 times 2 is 12. 12 plus 13 is 25. So this expression is 25 and this is 6. So 25 and 6 are relatively prime. That is GCD is 1. Now let's reduce 6 from this number. So 25 minus 6 is 19. 19 and 6. The GCD is again 1. Let's reduce 6 again. What do we get? 13. 13 and 6 are again prime, relatively prime. Okay. So even if we add 6, that is 2 times 3, it would still be relatively prime. So 25 plus 6 is 31. 31 and 6, they are relatively prime. So since that is the case, we can totally remove 2 times DE times EF. So removing DE times EF from the first part does not change the relatively prime property. So we remove both because it is 2 times. We remove the 2 times DE times EF. So we are left with DE square plus EF square is relatively prime to DE times EF. What is DE square? Is A. What is EF square? That is C. So A plus C is relatively prime to D times EF is B. So we have shown that given a continued proportion ABC such that they are the least in that ratio, then sum of any two of them is relatively prime to the third one. Of course, I have taken only 2 cases. I'm sure you can figure out the other case. So we have taken A plus B, we have taken A plus C. You can figure out B plus C is relatively prime to A. So that was proposition number 15 of book 9 of Euclid's Elements. Again, let me remind you, there is a link to a PDF book which describes all these propositions in detail with proper references to the previous propositions that has been used in this proposition. Please feel free to download it, refer to it, and if you think somebody else can benefit from it, please do share. That's it for now.